So, like Patrick said, we're going to be talking about malware behavior. We've seen a lot of very heavyweight talks today, so I'm going to give your brain a little bit of a rest here. This is not going to be really, deep. It's going to be very high level. So a little bit about myself. My name is Thomas Reed. For those of you that don't know, I work for Malwarebytes. And when I am not, managing products or reversing malware or whatnot, I am an avid photographer. So let's jump right in here. I only got 25 minutes, so let's look at some specific behaviors that malware generally likes to have. So persistence, obviously, that's a big one. If malware can't stay running, what good is it? Now, in certain cases, it's not that important, but the majority of the time, malware wants persistence. Malware also often likes to make system configuration changes. So, changes to various system files, host file, sudoers file, stuff like that. Installing system configuration profiles, that sort of thing. Malware likes to be hidden as well, obviously. So there are a variety of ways that malware tries to stay hidden on the system. And then malware needs network communication as well, for downloading additional payloads, for exfiltrating data. So obviously those are some pretty important capabilities that malware has to have. Problem is, these are also all things legitimate applications have to be able to do. So where do you draw the line? Like what's malware and what's not? So the difference here really keys off of those differences and what kind of behaviors are suspicious and which ones are not. And sometimes this is a very blurry line. Sometimes it's very sharp. It just depends. So we're going to look at a whole bunch of these kinds of suspicious behaviors that you might see. So we're going to start with kind of, the easy, obvious stuff. So launch DT lists. We've talked a lot about launch agents and launch daemons. So here's an example. This was found in some malware that we identify as bad word. That's more because John Lambert, who discovered it, didn't really name it, and we had to call it something in our database. So, that's what we called it. And this malware, basically, it was a Microsoft Word macro that did a sandbox escape and wrote a plist file to the system. Interestingly, it actually stole the code from Adam Chester, who wrote a proof of concept. Even the name of this thing is from his website. But obviously here you see in this plist, if you can see it back in the back, there's Python code being executed straight from the plist file, and that's like you'll never see that in a legitimate plist. At least you shouldn't. We would hope you'd never see that in a legitimate plist. In this case, that opened up an interpreter backdoor. You'll also see launch lists that are pretending to be apples. This is a very common technique. It's kind of a lame technique, and I wonder how often it actually works, but I see it all the time. So you can see in this screenshot here, those are just 3 examples from Evil Egg, Darth Minor, and Lame Pyre, all of which appeared late last year. So that's highly suspicious. The problem here is that there are a few legitimate com.apple.plists that you'll see outside the system folder. So you can't just automatically assume that every com.apple.plist that you see in the user's launch agents directory or somewhere like that is automatically bad. Some are actually legit. Cron tasks have been mentioned a couple of times over the course of the conference here. These days, cron tasks really are not used much. I think the only thing that I've seen a cron task for in legitimate software lately was really old versions of SuperDuper. So really, if you see a cron task being used, it's probably malicious, unless maybe you set it up yourself. So here we've got two different examples of cron abuses. The top one there is from some malware that we call vSearch. It's also called Pirate, which was discussed yesterday. And here it's just running a process called stateliness.s.hu. Nothing suspicious about that at all. And then the bottom one here was actually from an old Word macro malware. And you can see it calls this, Apple script that does a shell script that writes a file out, loads it up in cron, and then deletes the file. So you've got this task going at all times, but there's no evidence left on the hard drive. But you can still see that the cron task is there. We mentioned sudoers file changes as one of the system configuration changes that malware likes to make. You can see here two examples from the malware Doc and Proton. The top one was from Doc, and what that does is it allows the current user, which was test in this case, to do anything with sudo without having to have a password. The bottom one there was from Proton, and that basically sets the system so that there is one single sudo timer going. So most of the time on macOS, you open up two terminal windows and you do sudo in one of them. It starts up a timer going. You have a certain amount of time to continue using sudo before it asks you for a password again. The other terminal window does not have that same timer going. If you do sudo in there, it starts a new timer. This actually makes it so that if you do sudo, any process anywhere on the system can then use sudo without a password. So if you can imagine, malware could sit there in the background just waiting for you to run something with sudo and then pounce on that and get a privilege escalation. And these would typically be used in cases where the malware was able to somehow get root access to write to these files, but maybe didn't have continued root access to do later operations and wanted to be able to have that capability. Hosts file also is one that's commonly manipulated. Most of the time that I see it manipulated, it's actually because somebody has installed a pirated version of some Adobe product. So if you see that, it's not malicious, but it's highly suspicious, and that machine probably needs a little once over just to make sure the user hasn't installed something they shouldn't have. But some malware, such as Doc, which we'll be referring to repeatedly because it's done some very interesting things, actually use this to block a whole bunch of Apple servers as well as VirusTotal. So that's really, really suspicious. You should not see either of those getting blocked in the hosts file. Another vSearch example here, and there are going to be several of these kind of chained together. So vSearch, or Pirate, used a hidden user. So when it installed on the system, it would create a user with an ID of 401, which means that it's totally hidden, doesn't show up in system preferences or anywhere else. You kind of have to know what you're doing to spot the user. This user was used with a PF rule, and it was used to run a proxy. So all the user's HTTP traffic was proxied through a process that was running under that user. So this was a good way to hide that proxy and keep it from being noticed. And it was a good way also to for research to actually inject ads into your HTTP traffic. This could very easily have been used to sniff your traffic. Fortunately, it wasn't. But in general, a hidden user is a big red flag, and if your system's got PF rules on it that you don't know are there, that's also a huge red flag. Another case of proxy settings is in Doc. Doc, you can see here, it ran a proxy through port 5555 on the local host. It did it differently, so you've got to kind of keep an eye on a variety of different ways that proxies can be set up, proxy settings, PF rules, etc. Another way to do proxying is through trusted certificates. So you kind of have to keep an eye on your keychain and making sure that there aren't some weird certificates in there that shouldn't be there. So the Doc malware actually installed this Komodo certificate here on the right side, and it used that to proxy not just HTTP, but HTTPS traffic. In that case, the intent was not to inject ads, but actually to sniff the traffic. We've also seen MITM proxy, which is an open source proxy tool. Lately, that has been used in a lot of adware and malware, both for the purposes of injecting ads and sniffing traffic. And as was mentioned yesterday, Titanium Web Proxy is another one that's now joined the fray and is being abused by malware. Both of those last two, they're completely legitimate, open source. There's nothing wrong with them, but if you see them on a system and you don't think that user has a reason to have them there, that's a huge red flag. Probably they're there for malicious purposes. Process behavior is another big thing that you've got to look at. So for example, anything that's running from temp, if you look at the list of running processes and something's running from temp, that's a huge red flag. Slayer is just one example here, but there are many, many others. Most adware droppers will do this sort of thing. They'll curl something down into the temp folder and then run it. So in this case, this just shows that Slayer was running a script that curled a file down into the temp folder and was running it. And I think we've seen that code already at least twice, maybe. So Slayer has been well covered at this conference. Running from hidden locations, that's also another big no-no. And when I say hidden locations, I don't mean like, /user, because it's a hidden folder, but it's fairly normal for processes to be running out of there. I mean hidden as in like some weird folder that starts, the name starts with a period, so it's hidden from the user. That's not the way that Apple typically does things. So, and it shouldn't be the way that normal, legitimate software does things either. You can see in this case with Evil Egg, in this plist file, it's running an executable that is invisible from a folder that is also invisible. And that's really, really suspicious. In the case of Real-Time Spy, it was actually an application that was made invisible and loaded through a login item instead of a launch agent. Process behavior here, this is just another way that some of this malware gets installed. It's through Apple script or Automator scripts, which is kind of interesting. And it's weird because all this is a carrier for a shell script. So in both the case of Darth Miner and Langpire, Automator scripts were used, and their entire purpose was to do nothing but run a shell script. So this one here, this is from Darth Miner. You can see that it curls something down from kind of a weird URL, and then pipes it to Python. And then it curls something else down and unpacks it and runs it. So that's pretty suspicious, obviously. Just that behavior itself and the fact that it's wrapped up in an automator script is even worse. Now, in the case of LameTire, the script was, it was kind of lame malware, but the script was much more interesting. So it had this long bit of base64 encoded data, and it took that and decoded it and piped it into Python. And then, while that was running, it went into this loop here, and it started doing a screen capture, and it did it in such a way so that the sound wouldn't play, so you wouldn't know that a screen capture had been done. Saved it in the temp folder as a file named alloy.png. I don't know why that file name. And then it used curl to upload that to a command and control server. And it did this over and over and over and over again as fast as it could. So as soon as it's created and uploaded a screen capture, it's doing it all over again. This was kind of noisy, though. I mean, obviously, this is a lot of web traffic going out because it's basically constantly uploading something. But even worse, the whole time this was running, up in the menu bar was a little gear icon for Automator, just going around and around and around. And I think somebody mentioned that yesterday and said that you could make it so that it would just run for like half a second and then go away. Evidently, they didn't know how to do that, so it just would keep going and going, and so it was right there just sort of waving like a big red flag at you. Network connections are another thing to look at, especially network connections to Tor. Now, Tor is a legitimate thing. It's not malicious in and of itself. But if you see a weird process that shouldn't be on the system communicating with Tor, that's a problem. In this case, Doc used this plist here, com.apple.safari.proxy.plist, nothing suspicious at all there, right? And you can see here in this code, it was directly running an open source tool and using that to proxy traffic through a .onion address. So that's like just about everything about this is suspicious. But specifically, if we look at that Tor traffic going out through some random plist file, a process launched by a random plist file, that's really sketchy. We also have seen lately a growing number of processes signed not with an Apple certificate, but with ad hoc certs. I'm kind of shocked that this still works. I would think that Apple would not want this to work at all, because these are things that can run because they're not unsigned, but Apple has no control over them. Apple can't revoke the certificate. So this was done by both vSearch and some adware that was otherwise pretty uninteresting that we call FaceBump. It imitated the Facebook app. And if you look at the code sign information for both of those, you'll see team identifiers not set, signatures listed as ad hoc. The bundle identifier can look legitimate, or it can be kind of sketchy. Like, I don't know what they were thinking with UPD dash some long number. That doesn't look at all like a bundle identifier. But if you see applications that are signed like this, that's a really, really big red flag. A shell script as an app executable. So, you're used to seeing a Mako binary in there as the executable inside of an app, but you can actually replace that with a shell script. The only time I've ever seen that done has been with Schlayer, which I'm not going to dive any more deeply into this script here because it's already been discussed at least twice over the course of the conference, but suffice it to say that if you follow this script through, you'll go down a deep rabbit hole of repeating, obfuscated scripts and curls and et cetera, et cetera. And it all starts off from this shell script inside the app bundle in the contents macOS folder, which is really weird. So if you see that, that's not right. No legitimate software does that. And then a couple more items here regarding installation. So in this case, we're talking about vSearch. vSearch, and this is kind of an older version of vSearch. It did some analysis avoidance directly in the install process. So inside the PKG file, it had a pre-install script. That pre-install script, I've trimmed out a lot of it because a lot of it's fairly uninteresting. But if you look here, what it's doing is it's calling IOReg, and it's getting some information about the device. And then it's piping that through a whole bunch of sequences of, awk and grep and whatnot to try to get the vendor name out of there. And you can see very, very clearly there, it's not even obfuscated in any way. It's looking for Parallels, VirtualBox, Oracle, and VMware. And that was fairly effective at actually detecting a VM and bailing out. So you can see there it says is VM equals 1, is VM equals 2, or it equals 0. And so if it was in a VM, it would bail out after that. This was pretty easy to get around. If you had this sample, you just, as Jaron was talking about, you expand the package with PKG util. You change that if else, and you flatten it again. And this wasn't signed in any way, so you didn't have to worry about a signature. But that kind of behavior, that kind of analysis avoidance is really, really very common in malware. It's not always quite this obvious. There has been some discussion about analysis avoidance is very sneaky at the conference. This is just blatant and it's easy to spot. Unfortunately, they're not really doing it this way anymore. It's gotten to be sneakier, and you don't see this kind of obvious analysis avoidance anymore. And then we've got flashback. Now this is a flashback to almost a decade ago at this point. So this is very, very old malware. And it actually did the installation in the pre-install script. So you run the PKG file, and maybe you decide to bail out and you cancel the installation, you quit the installer. Too late, it's already done. So this kind of thing is pretty nasty. So you can see here, actually in this case, the pre-install script was a Mako binary, which is fairly rare. I mean, as was mentioned, you can have really anything as the pre-install script, but traditionally it's like a bash. Sometimes, I guess, a Ruby script or something like that, as Jaron mentioned. In this case, it was a Mako binary. I think this is the only time I've ever actually seen that. And a Hopper screenshot would have been a little bit too big to really meaningfully display here, so I just sort of stuck to showing the strings. Just to make sure that you can see it in the back. I'll zoom in a little bit. So you can see a lot of nasty things here. You can see a reference to Little Snitch. So this script would actually look for the presence of Little Snitch. And if Little Snitch was present, it would bail out. It would not install any of the stuff that any of its payload. And the reason for that is that this was going to exfiltrate some information, and if Little Snitch was there, it wouldn't be able to do so. And you can also see a number of other nasty things, like I've got outline there that it did launch control load, and then it set an environment variable. It set a dynamic library to be inserted into the system. So lots of nasty stuff there. There's an SU command in there. There's, I mean, all kinds of nasty stuff. It's and this was all done in the pre-install script. So it happened before you even, like you would never have realized that anything had been installed if you didn't complete the installation process. And that's something that I'm kind of surprised we haven't seen more of, because the pre-install script is the perfect place to drop some nasty stuff on your system. Because it happened so early in the process. So that is it. Pretty short and sweet. Any questions? All right.
What's the craziest thing you've seen recently in the wild? Or you'd say, wow, that is mind-bogglingly kind of interesting.
Craziest? There really hasn't been anything really wildly crazy lately. It's actually been kind of quiet this year. We've seen a lot of adware, a lot of pups. The worst stuff we're seeing right now really comes from the pup world. We're seeing things like lots of, kind of like polymorphism. We're seeing a lot of pups that are proliferating in numbers, and every single one of them has a different name. And the one in question here that I'm thinking of, it started out as Advanced Mac Cleaner. So you guys are probably, at least some of you are probably familiar with that. It'll put up a window and it'll actually yell at you. It'll say, your system is, I forget the exact wording, something's wrong with your system, you'll have to clean it now. So it really tried to scare you. And then all these other variants of it are all exact duplicates of that app. And there are dozens and dozens of them at this point, and more appearing almost every day. So, but yeah, like as far as really cool, interesting, we're really not seeing it. We've got all these theoretical exploits. We've seen some really great 0 days. At this conference, and nobody's using them in the wild. Last year, I presented about code signing and how you could use that to actually establish persistence by worming an application. And still, nobody's done it. My paper is out there. It's at the virus, I think it's up on the Virus Bulletin website.
You sound disappointed.
And nobody's done it. Yeah, I mean, all of us in this room, we could do, each and every one of us could do malware better than the malware authors are doing it right now. And I don't understand why it's not being done. Not that I want it, but it would make my life more interesting, at least. Yeah.
And do you see stalkerware on Mac at all? And what is Malwarebytes' policy for classifying that?
Yeah, that's a good question. We definitely do see stalkerware. That has become a big thing these days. Lots of talk about it. We have actually been very strong against stalkerware before it became called stalkerware. We will detect any kind of, not just malicious spyware, but so-called legitimate spyware that you can go to a website and buy, which I guess is what they're referring to when people say stalkerware. And we'll detect all of that stuff, and we have on the Mac side, we have since I've been with the company, basically since the product first existed. So.